Thank you everyone for attending. My name is Christoph Pettis. I'm the CEO of PostgreSQL Experts. We're a small Postgres consultancy based in Alameda, which is that way, I think. And the slides will be up at thebuild.com. That's my personal blog. This is the company website. Hire us to do something. And that's my Twitter handle. And there's my email address. Okay, so today we're going to do the impossible, which is talk about security. Security is not a single topic or practice, and there is more folk wisdom about this than probably curing headaches. But the reason that, that it's very hard to have a comprehensive view of security is basically everything has a security aspect. So the problem is perfect security is impossible. And so all life is a trade-off and followed by certain death, but we'll do what we can anyway. Yeah, so this talk is probably going to come off something like this because I'm going to rant at you about things you must do. And the problem is that the situation is you can achieve perfect security by taking your computer, locking it in a box and burying it somewhere and never booting it, which greatly reduces its utility. So everything is a trade-off between the utility of the system, the convenience of the users, and how secure it's going to be. So nobody does everything that I'm going to talk about here, and that's okay. Don't feel guilty about it. Just make sure you understand what risks you are creating and mitigating when you do and don't do certain things. So we're going to talk, at least briefly, about the various components of the stack. The underlying host operating system, Postgres itself, including access to the database server, the data that's in Postgres, and which includes encryption and permissions and things like that, and the application, which is, all in all, the application is the most important part of this, and we'll get the least conversation because that's just the unfortunate nature of life. So the first thing to remember about Postgres is there's nothing magic about a Postgres server. It's just a program that's managing access to a bunch of files. So if someone can get access to the server, none of the rest of this matters. One of the things that you will occasionally hear is they say, well, okay, yeah, maybe somebody can get access to the server, but they can't get access to the Postgres user, and Linux has permissions, and this will be fine. And don't assume that. If they can get to the box, assume they can get root and can do anything on the server. Because they probably can. Privilege escalation bugs are like, you can't move for hitting a privilege escalation bug. Everybody patched for this? Everybody know what this is? Who doesn't know what this slide is referring to? Okay, go and Google it. Because this means any local user on any Linux system that's shipped in the last 15 plus years can get root if they can get onto the box, including all those routers and all those light bulbs. Doesn't that fill you with confidence? So the first rule about securing any host is minimize the attack surface. Always put your database server behind a firewall or VPC, or inside a VPC. Never, ever expose port 5432 to the public. This brilliant idea you have where your remote application is going to just connect directly to the database via 5432, it's a bad idea, and you should feel bad for even thinking that. For example, there have been Postgres bugs that will allow you to crash and corrupt a Postgres server if you can get at 5432, even if you can't connect successfully. Even if you have no privileges, you could still, those bugs, as far as we know, have been completely fixed, as far as we know. And remember, if you're on AWS or any other hosting service, you're basically, everything you put in is on the public internet. It's sitting on the sidewalk, listening to packets. Don't trust the Amazon's routing infrastructure to keep you isolated from everything else. Don't allow direct SSH into the database server. So require a hop through a specific bastion host. Make them work to get into at least one more box. And restrict access to that bastion host by VPN or IP. Don't just leave port 22 or any other port just dangling out there in space, allowing it. I mean, come on, everybody knows about doing port, everyone knows about changing SSH to 2222 or 10 zeros or 10022. Nmap will find that. Don't just move the port around and feel like you've done anything for security. Don't run unnecessary services on the database server. Don't run your app server there. Don't run your IRC server there. Yes, I've seen this in client installations. Don't run your general purpose mail server. Obviously, if you want a mail transfer agent to push out errors and things like that, that's fine. Don't run a giant, if you have a giant mysterious Java VM that the previous DBA installed, that you're not sure exactly what it's for monitoring, kind of find out what it's there for. Or just, be proactive. Run Nmap against it and see what ports are actually being advertised. This could be surprising to you. It's like suddenly there's like these ports and you wonder, why are these services on my database server? Use IP tables or something like that to block local access, or whatever your favorite, whatever you want to do for firewalls. Just restrict access to just expected users. Don't rely on just pghba.conf to completely secure the box. And this is especially important in cloud hosting environment because all sorts of random packets are going to come flying in and bounce up against your server. And do basic stuff like use specific users in sudo. Never, ever, ever allow direct root login. I hope, it's 2016. I hope we all know that. But I still, will sign up a new client and it'll say, OK, send credentials. And they say, well, it's root at public IP address. It's like, okie dokie, if you say so. Have horrible passwords and make people use password managers to store them. Don't make people memorize passwords because if you can memorize it, it can be guessed. If you have a system, because we still haven't figured out how to do security right, you will ultimately have supercritical passwords, like the root passwords on hosts and things like that. You'll need to store those somewhere. Ideally, split them. Give them to two, take the password, split it in half, and give it to two people. Ideally, two people who don't like each other very much, so that you don't have these fabulously sophisticated root passwords floating around someplace. And keep your systems up to date. Always subscribe to PostgreSQL announce, because there will be security patches that are released, and you'll want to know about that, or data corruption bugs, or all that kind of stuff. If it's a security-related update, or frankly any other update, apply it immediately. Come up with a strategy. It's very painful to log into a system that's running Postgres 9.3 and it says, and they're running 9.3.0. And say, well, why are you running 9.3.0? Well, upgrading is such a big risk. Trust me, running 9.3.0 is a much bigger risk than upgrading to the most recent version. And also subscribe to the appropriate security list for your platform. Find out about things like Dirty Cow and stuff like that. And keep up to date with the patches. Make it someone's job to do this. Make it someone's job. Make sure they do it. Never, ever allow a critical security patch to go unheeded. This kind of stuff happens all the time. We are always finding critical security bugs in operating systems. And the only way to be secure against this is to patch, because the time between an announced vulnerability and it being available in the wild is about 30 seconds. So do it. So in a perfect world, you use multi-factor authentication for all your logins, for your VPN, for all this stuff. Use LDAP. Now, I'm going to use the term LDAP a lot. By LDAP, read LDAP or Kerberos. That gets a little tedious on slides over the time. The point is to have a central place of truth for your logins, so that when you have to revoke someone's credentials, you can revoke it everywhere. Because it is very common that when someone leaves, you discover that their passwords are still, that they have logins still hanging around in various services, and that's a big issue. And require password rotation. If you're anyone who's subject to PCI compliance because you're handling live credit card data, I am. Password rotation is required by PCI, but it's a good idea in general. And at an absolute minimum, never reuse passwords. Don't have the same password for the Postgres Linux account and the Postgres login to Postgres and all this stuff. Make them at least have to guess a bunch of different passwords. The reason you want to do this and have good, strong passwords and you want to have two-factor authentication is Google up code spaces. This is a company that doesn't exist anymore because they didn't have two-factor authentication on their AWS console. And somebody got the password, logged in, and deleted everything. All their instances, all their backups, everything. And that company then ceased to exist. So this is why you want two-factor authentication. Make sure your machines are properly secured in the data center. You may have to ask some unpleasant questions of your hosting environment, like what kind of physical access controls they have, which means real security, like access control, video, man-trap biometrics, that kind of stuff, so that people can get to the hardware. Because if you can get to the hardware, there's a lot of damage you can do that's very hard to defend against. And make sure your cloud provider actually provides this stuff. Ask these questions. One hosting provider I talked to about this, no one had ever asked them what physical access controls they have. And the answer was basically none. So that was kind of unfortunate, especially because this was a company that was going to be handling HIPAA-compliant information. Okay, really briefly on pghpa.conf, because we can go into endless detail about this, but you can read the docs, you can understand what it does for you. The first rule is, see this? No, you don't see that. There's no such thing as trust authentication mode. It never existed. You'll read about it in the documentation. The documentation lies. It doesn't exist. Trust me on this one. Always require specific users, even for super users. Yes, everybody kind of gets sloppy and logs in as Postgres and does things as Postgres. Don't do that. Give everyone their own login so that when you have to revoke, so if somebody leaves the company, you can easily revoke that individual's login. Don't use the Postgres Unix or database user. Require specific logins. Because again, if you have to revoke somebody, that means there's one fewer live password kicking out there you have to change or remember to change or forget to change. LDAP or Kerberos or something like that is your friend here. LDAP is not your friend. LDAP hates you and wants you to die, but having some kind of centralized way of managing these users is very important. So what about the Postgres user? Well, it exists. It's going to have to exist. So create a nasty password for it. Keep it in dual split custody. And never use it unless it's a dire emergency and there's no way out of a bind you're in. And don't allow non-local logins for it. The only way anyone should be able to get to the Postgres user is they first log into the box, sudo to the Postgres user, or from their local user, and then get in. Don't have people just randomly connecting from the outside as the Postgres user. And don't use it for routine system administration tasks. Yes?
Is it possible to do it just for the Postgres user?
Sure. You just set it to pure authentication only. Is the right? Yeah. This is something I've just started to do. This is a relatively new recommendation. Listen, and the reason was I was terrified by something I saw that I didn't expect to happen. Set it to the specific addresses that you know they're on the right networks. The standard usage of this is you say listen address equals star, which means bind to every address on the host. I always did that. Seemed like not a problem. And then I brought up a host that I thought was in a VPC, and one port was on the VPC and one wasn't. And that was the default configuration for that, is they would always leave one public host thing dangling outside the VPC. So now, I call this for the brave. You really have to know what you're going to get, because also what happens if they change the system configuration, you reboot and suddenly you have a new port. And that happens on host providers. In a cloud environment, you can't always guarantee they're on the VPC. Frankly, you can't guarantee it on any environment, but cloud environments are particularly bad in this regard. Yes, sir?
So basically, if it's inside VPC and has access to only application servers inside VPC, that's fine to use star, or you...
Well, you should know what addresses you want it to bind to, so just specify those rather than say star, because what happens if the configuration gets changed and it gets rebooted? Or you forget to save a change permanently into a config file, and it gets rebooted, and suddenly a new interface comes back up. You'll probably no one will. You'll still be able to get drinks at a bar if you say listen address equals star. It's like you won't be publicly shunned, but I prefer now to list all the addresses so that I know for sure what addresses it's going to bind to. I don't believe list and address lets you do a CIDR. I believe you have to have a full-length IP. So again, use LDAP, Kerberos, something like that to manage credentials. Every user and role should have its own Postgres role. So make sure that, so you shouldn't be logging into it as web, unless you're the web application itself. You should be logging into it as Fred. And only grant the permissions this role needs. If this is starting to sound like it's going to be very tedious and a lot of work, you're right, it will be. But this is the way, if you really want to lock down your database, this is what you do. And this is basic stuff. Like a data analyst probably doesn't need to modify the schema. So why allow that permission? Remember, every single thing that a data analyst who has direct PSQL access or runs pgadmin is exactly the kind of person who goes to lunch, stay with everything logged in. If they can start manipulate the schema or dump the whole schema, well, somebody might come along to the terminal, or that machine might get compromised. So if you're not using LDAP or something like that, Postgres passwords must be singletons. The only place in your entire universe that the Postgres logins should be used is for this particular thing. Don't reuse passwords. The problem is, to this day, Postgres stores its passwords locally as MD5 hashes, which might as well be clear text at this point. So don't reuse them anywhere else. Because if somebody is able to get access to the Postgres version of the database of the password, they'll be able to crack it. Garden Variety PC can take apart MD5 in no time at all now. And just make them horrible and long. Make them cut and paste them from a password manager. Don't have things people can memorize. So this is the worst single anti-pattern from a security point of view, which is there's one user called web, which can do everything, probably owns the database, and may be a super user. And this is made worse because some migration systems, like Rails, like Django, kind of force you to use or expect you to use the same user for general web operations as for applying migration. So revoking the schema access permissions from them is a path that is being resisted by your framework. So fight that resistance. You can make it work in both Rails and Django, and I'm sure other things too. Create a separate user for doing migrations and deploys and things like that, and only use web for the application servers that need to do queries, basic queries against the database. And lock down this user to the app server IPs. Don't let it come in from arbitrary locations. In particular, don't let it come in from the Bastion host. Why would it ever need to do that? Unless somebody was trying to do something bad. Require SSL and CA certificate and CA signed certificates. You run your own CA if you want, but require it, especially in a cloud environment, because you don't know where these connections are coming from necessarily. Remember that that SSL without proper certificate authority management does nothing to prevent man-in-the-middle attacks. It's very so. There's and every API in the world. Unfortunately, APIs tend to be really bad about this. They tend to not use proper certificates, and so don't do that. Require this. So
There are certain cloud providers that seem to have trouble getting you to verify full.
Mm-hmm.
Like say that's not a secure.
Well, you have to. The question is, some cloud providers won't let you do verify full, usually because they're proxying something somewhere. And the answer is open a ticket and say that's not acceptable. Because, for example, for PCI compliance, that is not acceptable. So, create a business reason that they shouldn't do that behavior. So anyway, databases have sensitive information. Kind of why you have a database if you're a business. Just the customer and order info is sensitive. There's the. I believe it was Cardinal Richelieu or somebody of that nature who said, give me 5 lines written by the most honest man in the world and I will find enough to hang him. And this is true of order info also. It's amazing what you can find out just trolling order info from the most benign sites imaginable. And some things are really sensitive. So like credit card info, health records, utility bills. Utility bills are considered highly sensitive information, actually. For example, if you see someone with unusually high access, maybe they're running medical devices, and now you're starting to find out things about their medical records. And it's essential to protect this against theft. If nothing else, you don't want to be on the front page of Hacker News for the wrong reason. So the first answer a lot of companies do is they say, okay, we'll just take Lux, which is a full volume encryption, software encryption thing, and we'll layer it on top of LVM, and we'll layer it on top of EBS, and yeah, okay, now we're like getting, USB stick speeds out of our data, but we're secure because it's all encrypted, right? No. Full disk encryption is useless. Let me say that again. Full disk encryption is useless. Full disk encryption prevents against one thing, which is the theft of the media. It's great for a laptop, highly recommended for a laptop. But for your server, that's it. That's the only thing you get out of it. And that's a vanishingly small percentage of your possible threats. If the only threat you have now guarded against is someone breaking through all these the access controls into your data center, walking in, opening up the thing, unscrewing it, and pulling the disk out of the rack. But nothing else. The easy rule is if you can read it in clear text with PSQL, it's not secure. Because most intrusions are not by stealing the media. Most intrusions are they gain shell access, or they just got your application to send the data to them, and all the full disk encryption in the world won't help you there. But it's great for laptops. That being said, sometimes you got to do it, because sometimes someone will hand you a contract. Like if you do business with any utility in California, and you're getting raw customer data from them, they'll hand you a contract that says you have to do full disk encryption. Fine, sure, sign it. Do full, use Lux, use whatever you want. And make sure your key management is safe then. Don't bake the keys into startup scripts on the host, because you kind of blew the whole deal right there. Come on. The right way of handling this is per column encryption. Is always encrypt specific columns, not the entire database or the entire disk. You get better performance that way because it doesn't have to do the decryption on every disk access, and you get higher security. Key management here is a pain. There's no nice way of saying this. In a really secure environment, automatic restart is basically impossible because every time you push the automated ability to read the key, you've created a vulnerability because an attacker can read that key too. Sometimes you have to make a trade-off here, like putting into appliance and concluding, okay, that's secure enough. But remember, somebody with access to the box that can read the key out of a key appliance, that could be an attacker, not just you. So for restart, just assume a human being is going to be in the loop in a highly secure environment. Sorry. So you can encrypt each column as a text or a byte, each column that you want to encrypt. This is good for small items like credit cards, things like that. Or you can create a JSON blob and encrypt the whole JSON blob, which is more complex things like medical records and structure, that have structure, things like that. And of course, you can mix and match. You can have multiple columns that are encrypted, whatever you want. Use a well-known secure algorithm. Please don't roll your own crypto. I hate to have to tell people this, but some people do. Basically, the weakest algorithm you should consider is AES 256. This is considered, by PCI, this is considered the minimum standard. So never, ever roll your own crypto, because professional cryptography, MD5 was designed by very smart professional cryptographers. Just saying. Don't bake the keys into code or put them into repositories. GitHub has all sorts of great API keys in it, in public repos. It's really fun. You can find all sorts of ones there. So you often have to index this encrypted data. For example, your customer service representative may need to take calls. They say, I see this charge from you, and I have no idea what it is. And they give them the credit card number, and they have to look up the order to find out if it's valid or not. That happens. And obviously, if you're going to scan your entire database by sequentially decrypting each record at a time, that's probably not going to give you a great user interface experience. So there's nothing wrong with storing a hashed value or a partial, but be careful about hashing things because it's very easy to reverse some hashes if you have mass data. For example, PCI lets you store the first 6 digits of a credit card number and the last 4 in clear text. It's only 16 digits long. Really no hash in the world is going to be that resistant to that, so be careful about that stuff. Store the absolute minimum necessary, like for a credit card, only store the last 4 digits. You don't really need the first 6 for anything. And use a strong hash, SHA 256. Argon 2 is supposedly the new hotness on the block in this regard. So the question always comes up now, well, what about PG crypto? It's right there. It's sitting there in contrib, sort of looking at you plaintively, saying, I'm a cryptography module. So why not use it to encrypt the data? I mean, why not? It's great. It's right there. So here's what we do. We have our super secret table, and we call PG symmetric encrypt, symencrypt. This is a PG crypto function that does symmetric encryption of various types. Here's my credit card number. This one's not valid, just in case you were wondering. The password. And this is great. It stores this encrypted blob into the disk. We assume that card here is a byte A value because that's what you get back out. And then you look at the logs and there's that. There's the credit card number in plain text and the password. So yeah, that wasn't so great, was it? So be careful about what you expose in text logs because that diagnostic run you're doing with log min duration statement equals 0 to collect data for PG Badger that logs everything. Well, now you've gotten all the credit card numbers and all the passwords, and you probably didn't mean that. This is another good reason to always do the encryption in the application, not in the database, because in the logs, all you'll see are these nasty byte A values, which are encrypted. And log everything. Log connections, disconnections, log all the DML changes, so you know who did them. Make sure the logs are kept secure and they can't be tampered with, like use rsyslog or something that's shipping them off the box so someone can't modify them or just delete them to cover their tracks. PCI requires this, and it's generally a good idea. Make sure the log record can be traced back to an individual person. So for example, on all individual users, set log min duration statement equals 0, so that everything an individual user that logs in does is logged. You may not be able to handle the log volume of everything that web or something like that does, but anybody who's directly connecting using PSQL or PGAdmin 3, now PGAdmin 4, you should see everything that they do. But again, remember not to log sensitive information in clear text. So which is another good reason to encrypt in the application, not in the database. Don't give every developer production system access. Why do they need it? Yeah, I know DevOps, whatever. Don't do it. You want to have a limited number of people who have direct access to the production system. Not every developer needs production system access. And when production data comes out of production and you want to use it to prime developer systems, which is a great idea, I'm very much in favor of this, have a process to scrub it so that the data is still useful for development, but is not revealing sensitive information. People can't, restore the data into their development laptop and then start doing queries for their friends. Remember that your backups are also your data, so make sure that they are just as secure. Encrypt them, store them someplace that's hard to get to. And if you're using a shared cloud store like S3, make sure that this stuff is private, because S3's defaults are pretty good, but it's very easy to boggle it and suddenly have people be able to get at your backups. If you're really intense, you can use row-level security. I'm not going to go into a lot of detail because it's a fairly sophisticated feature with a lot to go into it. Conceptually, you can think of row-level security as a mandatory view that's applied to a table based on access controls, so it can filter out data, including columns and rows, based on the user who's doing the accessing. So users that don't have permission to see things that pass or fail a particular Boolean predicate don't see those rows. Similarly, you can screen out individual columns that way. You could, in theory, use this for multi-tenancy. I haven't seen this done across highly sensitive information, but you could do multi-tenancy this way, or have applications that don't need the sensitive data just flat out can't get at it because of these access controls. And after all that, this is usually not where breaches happen. Usually breaches happen in the application or in the client of the database. Most big credit card thefts have been because the point of sale systems were running Windows, an old unpatched version of Windows, and got malware, and they just started downloading all the credit cards directly as they went by. Oops. This. And make the user interface on your clicker good. There. So it's either they breach the application, they convince the application to do something bad, or the clients are infected with malware. Point of sale tills, compromised user workstations, things like that. That's where all this stuff, that's where these big breaches come from. Very rarely do you have breaches that are where they have direct access to the database. Probably, people remember the Ashley Madison breach. That was one of the few examples of where someone actually had access to the underlying database, and it was an inside job. So you do the basics. Always use proper parameter substitution in your library. In 2016, the fact that we're still dealing with SQL injection attacks is really embarrassing. Never build SQL by text substitution unless you absolutely have to. For example, you can't do parameter substitution on table names, so you have to do that way. But anytime you find yourself putting SQL together using text operators, think about what you're doing and whether parameter substitution is really what you want. Just remember, all user input is hostile and wants to kill you. Anything that comes out from the outside world will be constructed in the worst possible way. Make sure your application can handle it if someone submits a 500 megabyte form. Make sure they can handle what they put raw SQL into every field, things like that. If you're running a remote API, mobile app or something like that, require TLS 1.2. Not 1.0, not 1.1, 1.2. There's no reason not to anymore. For dedicated clients like mobile apps, always use proper certificate management, because if you don't, you're subject to man-in-the-middle attacks. It's very easy for someone at a college or a business to put up a compromised access point with the right SSID and harvest all the text that goes by. I got burned by that at a DjangoCon Europe. Make API keys long and rotate them. It's not, don't have 4-digit API keys, which I have seen. Make them big. They're just big random numbers. Ideally, you want them to be, if the application deployment platform you're on lets you bake individual API keys into, have individualized API keys, do that so you can do revocation on a granular basis. And of course, log everything. Do what you can, and there are lots of tools that will do this, but detect unusual access patterns and take action. Everyone's familiar with the CAPTCHA, with reCAPTCHA, right? You know how that works? You know where it says pick the things that have a squid in them? It doesn't care. It doesn't know what has a squid in them. What it's looking for is things that move too fast, or things that move in a pattern that represents a bot. What they are looking for is the human going, squids. Is that a squid? So do the same thing. Do you have a user who's suddenly able to type at 5,000 words per minute? Do you have a user who tries to log in at the same, within 5 minutes from each other from Palo Alto and from Bangladesh? MaxMind's really cheap. Do the IP reversal on this. Are the users starting to cycle through password, at least lock down on multiple password attempts and start doing delays and things like that? If you see one thing you can, if you have a non-PHP application, someone requests a .php file, don't just throw up a 404, but do something. If you're feeling particularly gruesome, you can do a reverse slow Loris attack and start saying, "I'll get back to you," and then 3 seconds later you return the error, because some script kiddie is trying to pound your site, and you might as well slow them down. Blocking, rate limiting, admin alerts. Because almost all of these attacks, you'll see weird shit happening before as it happens. One thing to remember is users will generally share passwords across systems. If you're running a commercial customer-facing site, most customers will not generate an individual password for each site they go into. People like us are the exceptions. They'll use ABC1234 on all of their sites. So you will get people who intrude and start doing things, and be aware of that. And use reCAPTCHA. It works pretty well for screening out this stuff. One of the reasons that these attacks are so successful is people don't care enough. Is make security testing a critical part of testing. Always write tests that deliberately try and get around security controls. Have your QA try to break the security on the site. This is a great thing for new engineers to do because they're new, they're all fired up, they don't have a lot of preconceptions about how your application works, so they don't know how it's supposed to work and how it's not work. And most importantly, if they break it, make sure everyone knows they did and give them high praise for doing so. Because culturally, you want this to be a rewarded activity. And of course, run appropriate malware detecting stuff. Don't allow people double-click .js extensions. Use the OS's antivirus tools. Everybody now, for all the bad press Microsoft has gotten, their current suite of antivirus tools is very, very good as long as they're all enabled, which they're frequently not. Follow Swift on security, very entertaining account. Hire outside penetration testing firms. If you're in the PCI world, you're familiar with this, but just do it. Qualsys is one. There are lots of them. And also get them that actually understand security, not just that run pen test scripts, because this actually happened to me. Is like I get a call from I'm being PCI audited on one of my sites. They say, we need you to disable your firewall. Why? Well, our penetration test is failing because the firewall won't let it through, which kind of sounds like what a firewall is supposed to do. And of course, what was going on is that they had this checklist they needed to complete, and they couldn't get to the host, so they couldn't see that there were any ports queued up. There were any open ports, which is a little bit like saying, well, I came up and I tried to break through the barbed wire around your house, and I couldn't get through, so your door may have been unlocked. Okay, whatever. Yes?
So do you know for sure that wasn't part of the pen testing?
Interesting question if this was social engineering. They were too cheap. They weren't charging enough to do that level of social engineering. It would have been clever though. In the end, what I had to do was open just their IP, and then they went through, discovered that only 80 was open on my host, and everything was fine. And so by now you're listening to this guy up here ranting at you, saying, do this, do this, do this, do this, and thinking, oh my God, we're doomed. It's a lot of work, and there are a lot of risks, and you have to pick your fights. You'll never be perfectly secure. You never know when someone's going to have a bad day at work and decide, you keep your employees happy, by the way. That also helps a lot. And even the most secure companies get intrusions. Even companies that do everything right, they just leave that one door open, a tiny crack, and someone walks through. Life is full of pain and despair. What can you say? But do have hope. Do as much set it and forget it security as possible. Because the more you have to fiddle with, the more you have a chance of doing wrong. The more you set up as being secure, the better your chances as long as you maintain it. Just do regular audits and destruction tests. Don't lose sleep, but do be paranoid. And more than anything else, make sure that and especially people who are in senior roles in a company, make sure that they care. Because the companies that stay really, really secure tend to be the ones where the CEO really cares that he never hear about a breach. Because all of these have trade-offs. And if you trade off the wrong way, you'll end up with an insecure system. And you'll always trade off. There'll always be some you decide, because any system that's useful is not perfectly secure, almost by definition. Just don't get complacent. Don't have convenience be the most important thing. And just be proud of it. Be proud that your system is highly secure. That's a lot of it is that people are proud of their performance. They're proud of their scalability. They're proud of their deployment speed. They're proud of how fast they can develop. But they tend not to be proud of how secure they are. And changing that will change more than any other single thing. And thank you very much. Any questions? I have stunned everybody. Yes. Yes, sir.
In product-based companies, how do we implement, like in case you are doing the security to the other DBAs, like where you are delivering the product and the other.
The question is, if you're a product-based company, so you're shipping a packaged software product that someone else installs, and how do you get them involved in the security thing? And that's a really good question. One thing that I'm always surprised when I get these things, and there's nothing at all in the documentation or the installation notes about security, that always surprises me because there must be something they could say about security. It's one of the things I would call, if I get one of these, I call the vendor and say, okay, what are the security implications of this? What ports do I need to expose? What ports do I not need to expose? What roles do I need to? So if you're a product company, having a security section near the front of the docs that says, you must do the following things, these are the vectors that people could use to attack. A lot of companies don't like doing that because they feel like they're implying something bad. But that's like saying, well, we don't want to ship a service manual for our car because it implies it may break down. Trust me, the customers you really want will care about that a lot. And if you have a really good security story on the sales call and when they evaluate the software, that will be a big plus, not a big minus. Yes, sir.
What's your opinion on the cloud database services? Are they secure enough?
The one I'm the most familiar with is RDS. I would say RDS is reasonably secure, or can be secured. By default, it's pretty secure. The main thing, the good part is that you don't have, no one has access to the box unless you work for Amazon. So in that sense, they've eliminated this huge attack surface. The bad news is the only way of getting in is 5432, so you have to make sure 5432 is really locked down. So always put it inside a VPC, for example, just step one. Make sure pghb.conf is set up so that no one outside of that VPC can get at it. Make sure your security rules in Amazon are locked down, so only the servers that you really know. Amazon provides pretty good security tools. The problem is they're fiendishly complicated. It's very easy to push the wrong button and suddenly something wrong happens, which is a good reason to come outside, grab a box, run Nmap, and make sure that you did the right thing. Because I don't always, I'll look at this giant JSON security group output and go, I think I know what I just did, but I would prefer to think about it as an attacker rather than try to audit, a human being trying to read a 20K JSON file.
One cool thing is they don't allow access to any file system functions.
Yeah, I mean, again, there's this whole, RDS in particular and other ones. The good news is you've eliminated this huge attack surface. So that part's really nice. The bad news is if something goes weird in the box, hard to say what's going on. Anything else? Yes? No? Maybe? Yes, sir.
You mentioned password rotation. I understand that it's a compliance issue, but where can we get data on how long that cycle needs to be?
Well, I just use PCI, which is 90 days. It's like I am not to be a little more analytic on your question, which is how long should a password rotation cycle be? I'm not aware of any academic work that says 90 days good, 120 days bad, 45 days bad. It's really, I think, everyone's intuition about what's annoying and what's not. I think PCI set 90 days because it's just about as short as it can be without rioting. A lot of these were determined by someone saying, if I do 60 days, everyone, my users will try and kill me, so I'll do 90. But it's a good question. I generally, if you're in that environment, you have a document that says you must do it every 90 days, so you just do that and call it good. It would be an interesting bit of academic research, though, as to where we get this 90 days from, because I'm not aware of any actual grounding on it, except it seems right.
Postgres password, MD5 format, is there any other way to change that?
They're not currently in Postgres. Yeah. So just assume it's clear text and make it a one-off. I mean, passwords are just big random numbers. You just want to make it as random make it hard to guess. So if it's a big long password, it could be stored as MD5, it could be stored in clear text, it could be stored as anything, as long as it's a one-off. The danger is that if it's not a one-off, somebody could grab the password out of Postgres and use it someplace else. Yes, sir. Password management. I like 1Password or FastPass or PassPack. As anything this side of the grave is safe, I think there is a trade-off, because in theory, if someone breaks that, they have all the keys to the kingdom. The alternative is what? You either use everybody, you give everybody the same giant password, at which point if that becomes broken, you're vulnerable. You make people write them down in a book, but I assure you people won't do that. They'll keep a notepad file, things like that. No, and your point, I don't mean to dismiss your point, which is it does create this single point of failure. I resisted using a password manager for a long time for exactly that, until I started thinking, well, is what I'm doing really any better than this? And I ended up concluding no, because usually the way passwords get compromised is someone goes to the other system and steals it. And if every one of those is a singleton, the damage is relatively small. That's my basic rule, is I just never use the same password twice anywhere. And it does mean if someone steals my laptop, gets in, manages to break the encryption on that, I'm in a load of trouble, and that's an interesting problem. But in terms of actual product recommendations, I like 1Password. Their story about how they do security seems very compelling to me, and I like PassPack. Others are fine, but those are the ones I have personal experience with. Anything else? Yes, sir.
What about the use of SSL certificate for authentication versus password?
Well, conceptually, an SSL certificate is a really, really big password. And the answer is yes. That for example, if it's especially in an API environment, where you can bake the certificate into the API client, into the API, I think that's I'm very in favor of that. So yes, and I should put that in the slides. Thank you.
Yeah, a small question. We are running some Postgres EC2, and we'll have IP tables and security group and HBA configuration for access.
Mm-hmm.
Sometimes it's really complex to maintain them and keep consistency. And do you suggest for example, do not use IP tables using security group HBA?
The question is to repeat the question, make sure I got it. If you're running an EC2 instance, do you need to use security groups and IP tables? And the answer is probably not. It's a little bit of a belt and suspenders thing, but the main thing that you would be blocking yourself against is you screw up something in one or the other place, and then the other one guards you. What I would really do is use a configuration management system like Puppet or Chef or Salt or Ansible, whatever your favorite is. Use Boto scripts and maintain that all as a single thing, so the chance of screwing any of that up is relatively small, and it also greatly reduces your workload in configuring these things. So, that's one of the things about EC2 that everyone should do and doesn't, is it's really automatable. I mean, it's elastic compute. So use all that stuff that it gives you. You know, the days, you know, the fact that you don't have to pick up the phone, whip out your credit card, and have IX Systems ship you a new box is like the best part about Amazon. So use that for everything. Anything else? Great. Thank you very much.